Good evening, React India. How are you all feeling? Ready for yet another React compiler talk? Satya, watch out. My name is Rajat, and I work for this company called Certa. Back in May 2024, this year, when the React team announced the revolutionary technology called React Compiler, we all were very excited to see what it will give to us. It's a built-time tool that is supposed to optimize your React code. And we saw two major benefits that could really help us. First, this will make my app lightning fast. I will never have to do anything about performance again. Second, I will never have to memoize anything ever again. So we opened a terminal and started integrating React compiler. The first thing we did was started the health check. The health check is supposed to tell you how many components that you have are compatible with the React compiler. And it turns out 82% of our components were compatible. That sounds like a good number. It also tells you how many libraries, the third-party libraries that you're using, are incompatible. And we had 0 incompatible libraries. So we dived straight into the installation. We first installed the Babel plugin. So the React compiler ships as a Babel plugin. And then we installed the React compiler runtime. This is the module that actually has the function that memoizes your components and hooks. And this is the Vite config that is required to run the Babel plugin. And note, this works with the beta version of the React compiler that was announced yesterday. Notice the target key. This is the major version of React that we are using, and the runtime module. This is the name of the module where the compiler is supposed to look for the memoization function. Ideally, with the beta version, you're not required to write this runtime module, but it doesn't really work without it. I think there's some bug. So we run a dev server, opened a browser, saw a bunch of blue memo labels, run a unit test cases, integration test cases, sanity suite, everything works fine. So we released it to a pre-prod environment, and we slept like a baby. So that is the end of a journey. Sounds like anticlimactic, right? Because what about the challenges? The performance gain that we were hoping for, and the no memoization dreams. That's where the experiments with the React compiler in production code starts. Let's first understand the scale and the stack of front-end code base at Certa. We have a mono repo of 25 packages. As per the React compiler health check, we have 3,500 components. And I'm assuming it's a mixture of components and hooks. We are using NX and PNPM. We are using React version 18.2 with TypeScript and Vite. Our first challenge was to understand why 18% of our components are not being memoized. Because that's a big number for us. It's approximately 600 components. And on top of that, we also wanted to understand, do we really want to memoize these components? So we went ahead and started looking into our most performance-critical parts of our application. So one such part is a highly configurable forms page where 80% of our users spend 80% of the time. And this is how it looks. A lot of the components were not memoized, which were ideally supposed to be memoized. So we started to figure out how to understand the reason why the React compiler was not able to memoize them. And it turns out the React compiler health check doesn't really tell you the reason for it. It only tells you the count of components that are compatible. So we patched it. We put this patch that actually lists down all of the reasons why a particular component is not being memoized. We stored it into a text file, wrote a script using ChatGPT, converted it into a CSV file, uploaded it into a Google Sheet, and create charts out of it. I was hoping that would be a total waste of time, but then Satya pointed out that it's a really good thing, and the React team can actually get help a lot by this. But that Google Sheet also later helped us a lot in cross-referencing the particular issue and where that particular file exists. But they were tough, like In the order of occurrences, there were 4 reasons. So the first reason was expected identifier got member expression key in object expression. So it turns out React compiler does not does not work well with computed properties with member expressions. And we had a ton of them in our code base. If you hover over it, you see a to-do right there. So I was hoping that the React team will later build it. It's somewhere in their roadmap. Similarly, the tag template with interpolation, they also don't work. They're also expected to be built sometime in the future. And that's what intriguing for us, because we wanted to see what other things that the React compiler team has been skipping out. And it turns out there are 70 such things. If you do a Google search inside the Babel plugin React compiler, there are 70 things that the React team is not supporting currently. And they went to beta. The another major reason was the infamous React hooks exhaustive depth ESLint disable. How many have it in the code base? Right? So it turns out whenever the compiler sees this comment, it skips the whole component. That's bad, right? So what is the solution for all of the problems that we discussed so far? One obvious thing is you can fix them, but it's not feasible. How can you get rid of computed property with member expressions? So we wrapped and moved them out. So we wrapped them in some parts in a function, some parts in a hook, and then moved them out so that the rest of the component, the larger component, can get memoized. But there were some legit bugs that React compiler helps us to figure out. Can anybody identify the bug here? It's related to ref. So tracker is a ref which, somebody said something. So tracker is a ref which, when updates, does not read into the component, and the disable gets a stale property. This is why React team says, please follow the rules of React. And it's one of the topmost rule of React that you should not be accessing, you should not access the current property inside the render cycle. But there were some annoyances also. How many of you are using a use previous hook or some version of it? That's a lot of people, right? And it works perfectly fine for us, but then it breaks a lot of rules of React. But changing it was a lot of hassle for us, so we decided to skip it. What about the performance? That was one of our major expected gains out of the React compiler, right? Let's first understand what performance actually means. 90% of the time when we talk about performance, we talk about delivery performance or bundle size. If we go one level higher, we talk about LCP, which actually affects our users, or FCP, which again affects our users. So LCP is largest contentful paint, and FCP is the first contentful paint. But all of these metrics are very rarely impacted by the React compiler. So again, we are back to square one. How do we measure the performance gain? So we started with the profiler. So this is the render tree of a particular interaction on our home page. This is the before screenshot, and this is the after screenshot. Do you see the gray area here? This is all of the part of the React tree that the compiler memoized and the React decided not to re-render. So that's a performance gain, right? This is another React tree. This is, again, from one of the most important performance critical part of our application, the forms page. This is the before screenshot, and this is the after screenshot. Damn, right? It skips like 80% of it. That's a great performance gain. But what about our users? They don't care about React render tree. They don't care about performance, profiler's performance. They care about visible performance. But how does React compiler affect it? So we turned towards interaction to next paint. So this basically means how quickly your page responds to a user action. So you click a button, you see a loader, and how quickly that loader appears. So the longer the render cycles are, the more time it will take for the browser to paint the next scene. But how do we measure it? There are two primary ways to measure it. You can open the performance tab in Chrome, and it's right there. It actually measures the interaction to next pane for every click or every interaction that you're doing with the page. Or you can use Sentry to measure the INP over an aggregated data of your real users' performance metrics. But unfortunately for us, there was no major significant gains there. What about the manual MIMO? Has the debate of to MIMO or not to MIMO coming to an end ever? So the answer for us is almost, but there's still a very long way for it. And let's understand it using a tale of two MIMOs. So it's time for some code. Perfect. Can you see the code? Yep. And just give me 1 second. Ah, okay. Perfect. So this is the application. It's a very small application which has this particular UI. Let's look at the code. So the code is straightforward. There is an app component which renders a parent component. The parent component doesn't really do much. It has a count state and a function to increment that count, and finally a button that calls that increment function. All of this setup is just to re-render the parent component. There's also a items array, and this is one of the most interesting thing here because the item array is always a fresh array, no matter what the contents of it is. On every re-render, there will be a fresh array. And since I'm not using any compiler here right now, so I'm manually memoizing everything. So I have a manually memoized child component. I have a manually memoized handle click. Let me put it here. It's actually very hard to code on a different screen, right? Yep, perfect. And let's also get rid of the compiler. Let's go to the browser. What I'm trying to demonstrate here is whenever I click on the increment button, the parent component re-renders because its internal state changes, but none of the props for the child component changes. So I do not want to re-render them. So we are looking at the components tab, and we see the the gray memo label, which means there is manual memoization, but there is no auto memoization. Perfect. And just one more thing here, in the child component, I also have a console log. So this console log actually tells me if a render function of this child component is called. Let's go here. Let's go to the components tab once again. Turn on the highlights and go back to the console, clear the console, and click on increment. So you see the child components are not being highlighted, but only the parent component is being highlighted. But if you look at the console, the child component's render function is being called, which means it's not being properly memoized. Do you know why is this happening? right? The items array. If you go here in the parent component, the items array, since the items reference is changing on every render, the items array is creating a new array of child components, which is destroying the older components and recreating the new ones, which is why the older components is not re-rendering. The child components are not re-rendering, they are being destroyed and recreated. And that is why you don't see the blue highlights in the dev tools, but you see the console log being called. Now, how do we solve this? We turn to the compiler. So let's turn on the compiler, go back to the browser, go back to the components. You see the blue memo label here, which means the components are being auto-memoized. If you hover over here, you see that tooltip which says it's auto-memoized. And now, go back to the console, clear the console, and let's click on the increment button. How many of you expect that the compiler will actually memoize the child component and not call its render function? Oh, okay, at least some people. So I click on this, and ta-da! There is no blue highlight, and there is no console logs, which is exactly what we expect the compiler to do, right? Perfect. There's one small thing. If you go back to the components tab, you see two memos, right? So one is what we are manually memoizing, and the other one is the auto memoization. So let's get rid of the manual memoization because the compiler is automatically memoizing him. So I go back to the parent component, and instead of using the manually memoized child component, I use the non-manually memoized child component. Now, again, to the same set of people, how many of you expect that the child component will not re-render? You expect it to be not re-rendered, right? Let's first see the components tab. There is no gray label of memoization, so it's good. We clear the console. We click on increment. What? This was not what we were expecting, right? So it turns out the compiler needs some of my help. So I can't remove the memoization. Let's bring it back. Okay, let's do another experiment. Instead of this onClick, I use an inline function for onClick. Can you guys see this? Yep, right? One important thing to notice here is the function inside the onClick is a pure function. So we expect the compiler to extract this pure function and put it outside of our components, right? So that it does not create re-rendering of the child component. Okay. Let's again do that, clear the console, click on the increment button. And the demo never works. Oh. Oh. Sorry. Clear the console, click on the increment button. What? So it turns out this particular optimization is still not available. And going back to our original slide, which is not this one. So that is why I said it's almost there, but there's still a long way to go. It's just a trailer of all of the challenges, all of the learnings that we had. There are a lot of things that cannot be presented in 30 minutes talk. So if you're curious, please reach out. There's a engineering blog, and we are also hiring. Thank you.